We are all very familiar with forward DNS name resolution. For example, if I want to know UI.com's IP addresses, I can run this command. The forward lookup will translate the human readable domain name to IP addresses. But what about the reverse case, the reverse DNS name resolution? For example, if I want to know the domain name behind 8888, I can run this command. It says it's dns.google. I can run a more popular command, which is nslookup. I get similar information, right? If I want more details, I can run dig command, use the X parameter to do the reverse DNS name resolution. This type of reverse name resolution is usable in many scenarios. For example, for email servers, they need to verify whether the incoming emails are legitimate. They will use the rDNS, or in network diagnostics, troubleshooting, logging, you need to translate the IP addresses into more human-readable domain names. The way rDNS works is the authoritative DNS server will maintain a special DNS record. It's called PTR record. Basically, it's a pointer to the domain name. So for example, from this dig command output, let's look into the answer. So the first part, 8888.in address.apa, this looks like a domain name, but in fact, it is the reverse DNS query name for IP address 8888. And then IN means internet, PTR means this is a pointer, a PTR record. And then the last part, dns.google, it is the result, the domain name. This is how it works if we are talking about internet. Let me use a client in the LAN part of my network to do a reverse DNS resolution using my LAN IP address. In the upper part of the screen, let me run Wireshark to capture the DNS packets. Okay, the packets capturing has been started. Then in the lower part client, let me see its own IP address. It's .1.123. Okay, then let me run dig command -x. Then let me try to see what's the reverse DNS name resolution result for my LAN IP address. Okay, see the result? You see similar PTR record. And this part is the rDNS query name, and then it still says internet, and it is PTR record. And here you see the fully qualified domain name. In the Wireshark section, let me stop capturing. So you can see the two packets. The first one was sent from this client to UniFi Gateway, and it is a DNS query. If I expand the DNS query details, you can see the query name is the one we saw in dig command, and then the type is PTR, domain name pointer, and the class is internet. This is the query, and then the UniFi Gateway replies with this answer, and the answer says, for your query name, the PTR record, the result, the domain name is this one. Okay, now we get result back, but you may wonder, was this answer at all? The part before the dot, in fact, it's simply the host name of this Linux client, and the second part, the local domain, is the domain name I give in my default network setup. So let's try to see this part, the host name. If I run host name, I can confirm I have this exact host name, right? And then in the UniFi network controller, if I go to default network, I don't have anything customized, but if I click on menu, you can see internally the system will use the local domain as the domain name if you don't change it. That's the alter setting. Now we understand where this fully qualified domain name comes from. There's still a missing link. I haven't configured any PTR record internally. Where this PTR record comes from. So in this video, we will dig deeper to understand where this result comes from, and in different scenarios, what problem we may encounter and how we can handle them. You may know Ubiquiti gateways use DNS mask to handle DNS and DHCP services. DNS mask is a very popular free software, and it plays an important role for this video because it handles both DHCP and DNS. To understand how reverse DNS works with UniFi Gateway, we have to first understand how the regular DHCP works, because that's the starting point. So in the lab environment, I have a Linux client in the lower part of the screen and a Wireshark in the upper part. So let me start capturing, and this time I'm only going to see the DHCP packets. And then in the lower part Linux client, let me force a disconnect of the wired network and then reconnect. See, in the Wireshark, 2 packets were captured. Stop capturing. Let's see the first one. The first one was sent from source R0, meaning the Linux client. The destination is a broadcast address, and then the DNS mask within the UniFi gateway will receive the DHCP request. Let's look into what's the content of the first packet. Then let's go to this request section. Scroll to the end. You see this section. It's option 12. It's about host name. Expanded, you can see this name. So basically what it means is during the DHCP request, the client will include its host name in the DHCP request. Where does this name come from? In the lower part of Linux, let me run hostname command. This is what I said. Linux client told DNS mask, okay, my host name is SSH Debian. That's it. Then let's look into the second packet, which is the reply. DNS mask simply hand out the .1.123 IP address, right? But internally, because DNS mask received the host name from the client, DNS mask will maintain a mapping between the IP address and the host name. Later we will see that. And after this process, in the Linux client, if we dig SSH Debian, I will get this correct IP address. I can use the fully qualified domain name, local domain, the same result. And then if I want to do a reverse DNS name resolution, I can provide its own IP address. I got this pointer PTR record back, and it's pointing to the correct domain name. Everything works like a magic, even though I didn't provide any information manually. So far so good. However, let me show you multiple issues. This is my lab environment. I use a UDM Pro as the gateway. I have 3 UniFi switches adopted, and I use 4 Linux virtual machines as clients. One of them, you already saw it multiple times, which is the lower left Linux, and the other 3 are the lower right 3 Linux virtual machines. Now for LAN, I have 7 different clients. And then in the upper right, you see the DHCP manager from UniFi Network Controller. All the 7 clients are listed. Good. However, there are 2 issues. First, see all the 3 switches. Yes, I have name here, but I don't have host name. From UniFi Network Controller perspective, there are 2 different names. The name column is only known to the network controller. The host name is the generic OS level host name setting. So you can see these 3 switches, they don't have host names. That's issue number 1. Issue number 2, see the other 3 Linux clients, they all have the same host name, Debian. The reason is they are virtual machines. I simply clone them from the same template. I never bothered changing their host name, even though during DHCP processes, you can see from the IP addresses column, of course, they receive different IP address. These 2 issues will impact reverse DNS. So if I go to devices, for example, the first one, if I click on it, in settings, I can see a name. But why I don't see host name? Let me SSH into this switch. Then if I run host name, you can see the command even doesn't exist. Then if I go to etc, let me see whether we have a host name maintained. No, it doesn't exist. Then if I try to see hosts file, it only has this IP address associated with the name. I don't see any host name maintained for the IP address we saw. So that explains why in UniFi Network Controller, in DHCP Manager, for the 3 UniFi switches, I don't see host name because the Ubiquiti software simply doesn't assign host names to them. Then what's the issue? The issue is from any client. Let me exit the SSH. Then if I do a reverse DNS query, this is the IP address for the switch we just checked, right? See, answer 0. It used this to query DNS mask, the DNS server, but it doesn't get any reply back. Why? The root cause is we don't have a host name assigned. So let me put this issue aside. Let me look into the second issue. From this lower right 3 Linux clients, let me run host name. Okay, you can see they all have Debian as the host name. And then in the left side is another Linux client. Let me try to dig Debian. You can see there's only one answer returned, and this answer points to .aa IP address. From UniFi Network Controller, you can see .aa is this Debian client, the second one. Why not the first one and the third one? Let's continue in the Linux client. Let me do a reverse DNS name resolution against 192.168.1.88, which is the one returned by previous command, right? Let me run this one first. Yeah, you can see the answer is 1 is successful, and it successfully point to the correct domain name, right? However, if I run the same command, the reverse name resolution, but against the other 2 clients, let me start with the 228. See, answer 0. It doesn't have the reverse name resolution done. Then try the other one, 96. The same situation, it fails. Then what's going on? Why for these 3 Linux clients, only the second one, the .1.88, it works? For the other 2, they both failed. So this is issue number 2. So in the third part of the video, we will explore what options we have in UniFi Network Controller to make the reverse DNS name resolution successful for all these 3 UniFi switches and the other 2 Debian clients. As I mentioned previously, for DNS mask in UniFi gateways, the way it supports reverse DNS is very closely related to DHCP. Of course, we want to see the DHCP lists, right? But even that simple goal is difficult to achieve in current UniFi gateways. The reason is in this Linux terminal, I already SSH'd into UDM Pro, right? If you are using the old router, for example, USG Pro, there is a CLI command for show DHCP lists. However, if I run the command here in UDM Pro, it's not supported. I am not aware of another way to find it out. And for standard DNS mask, it does dump the current lists to a file. However, it doesn't work in the same way for UniFi Gateway's DNS mask. Having said that, there is a list file existing in UniFi Gateway. Let me show you. It is in the run DNS config.d host.d folder. Then you can see there's a file called lists. If I cat this file, you can see it only has 2 entries. Let's try to understand, right? Remember previously we tried SSH-Debian client, the reverse DNS works, and for .1.88 it also works, right? For all the other clients, including the UniFi switches, the reverse DNS doesn't work, right? See what we have in this file? It has exactly the 2 successful ones. In fact, this file is how DNS mask in Ubiquiti gateways support rDNS. So basically this file maintains the mapping between allocated DHCP IP addresses and the fully qualified domain name, which is a concatenation of the host name and the local domain name, right? So that explains why for the existing 7 DHCP clients, only 2 of them work when it comes to reverse DNS, because there are only 2 entries in this file. Okay, we already explained why the other 5 clients, they don't have entries here in this file, right? Now what we need to do is we need to find a way to make them appear in this file. Let's start from UniFi switches. Let me still use the same switch. If I go to setting for this switch, for IP settings, by default it's DHCP. If I make it static, just by the available settings for static IP address, you can see there's no way to specify a host name. That means I even don't need to try. I already know by changing the IP configuration won't help us for reverse DNS. Then let me try an alternative way. In the Linux terminal, let me SSH into this particular switch. Let me go to CLI for this particular switch. The way is to telnet localhost, run en for enable. Now if I run the command show sysinfo, see it does print a system name, and this name seems to be a host name. However, it doesn't match what we see in the UniFi network controller for DHCP manager, right? For some reason, this one is not the active Linux host name when the DHCP happens. Let me try to force a change of the host name. So let me run host name, then let me give it a random name. Let's say switch 1. Okay, successful. Then let me save the change, write memory. Okay, it's saved. Let me exit. Then to force a DHCP refresh for this switch, let me reboot the switch. Okay, the switch is back, but even though after refreshing the DHCP manager, I still don't see host name for this particular changed switch. So either the reboot caused my change to be overwritten, or the host name I just changed is not used in DHCP process at all. So for whatever reason, that approach I just tried didn't work. Now I still don't like this result because I cannot do reverse DNS against my switches, right? You may know UniFi Gateway support DNS entries. So let me show you. Go to settings, then go to DNS. Here I can add custom DNS entries. So let me create an entry. It should be a host record, an address record, and the host name. Let's give it the same, switch 1. And then the IP address, let me use the switch current IP address, add. Okay, it's active. If I SSH to the UDM Pro, then let me cat the list file we just talked about. Okay, see, this time a new entry was added, the switch1.localdomain with the IP address of that particular UniFi switch. When we add a DNS entry, the system added a entry to this list file automatically. So at this time, I assume the rDNS should work for this switch. So let me try. Let me first try reverse one by using the IP address. Okay, see, it returns a PTR record. Here you see it doesn't have the local domain because when I create the DNS entry, I didn't specify a local domain as the suffix, right? So that's why here we only see switch 1. It matches exactly what we specified in DNS. So this works. Then let me try the forward lookup. Okay, it also works. It returned the correct IP address. Before we move on, if you want to use this approach to add the rDNS support for your switches, make sure you use static IP address for your switch. The reason is when you specify the new DNS entry, you need to hardcode the IP address. So that's why you don't want your switch IP address to change simply because it's not using static, it's using DHCP. Okay, now let's move on to the Linux clients, the second issue. To resolve the second issue, let me use two different approaches. They both work. As we mentioned previously, for the 3 Debian clients, they all have hostname Debian, which caused the issue, right? And for this .1.88, which corresponds to the client 1, rDNS works simply because I restarted the client 1 first. So it got DHCP first, and then it got an entry created in the backend of the UniFi Gateway, the list file, so that this one works. But once client 2 and client 3 were restarted, there was already an entry in the list file, so these two clients were not added to that file. That's why for them, rDNS doesn't work. Let's validate it for client 2, client 3. Let me try dig against client 2, 1.97. Okay, doesn't work. Then for client 3, 1.228. Okay, also doesn't work, right? So for client 2, let me use the approach by changing the host name. The root cause is due to host name, right? So let me change it. I need to use sudo. So let me name it as Debian2. Save it. Okay, then edit another file, which is hosts. So let me change them accordingly as well. Save. Then let me reboot this Linux client. Okay, it's rebooted. Let me check the host name. Yeah, it's changed from the UniFi network controller. Let me refresh the DHCP manager. Okay, see, we have a Debian2 as the correct host name, right? In the left side, if I do a reverse DNS against the second client, see, this time it works. So this is the correct domain name. So the first approach works already. Then for the third client, let me try a different approach. So let me go to this particular client. This is the client device view. I selected the client 3, then go to settings. See here, I can give it a fixed IP address and I can assign a local DNS record. But by default, the local DNS record is disabled. Only if I give it a fixed IP address, this local DNS record will be enabled. So let me do that. I'm okay with this fixed IP address. I don't want it to be changed. Then for local DNS record, let me say Debian-3 local domain. Okay, apply changes. Then if I go to the DHCP manager view, the Debian-3 for this client 3 has been changed. And then here I see a local DNS record. In the SSH session, let me do a reverse DNS query against the client 3, which is 1.228. Okay, see, it works exactly as we expected. And then the forward DNS lookup should also work. Yes, it works. Okay, so we tried two different approaches, both work. At this moment, if I display the list file again in the SSH, see, now it's much busier. We have the Debian2 entry because we changed the host name on the Linux level. So this entry was added during the DHCP process, right? And then we see another new entry, which is for the Debian3. This one was added because we created a local DNS record. You know what? If now I go to the policy engine, DNS, you can see now I see two entries. So the one we assigned to the client, the Debian3, the local DNS record also appears here. So basically what we created there is simply a host or address record for DNS. Okay, it's time to end the video. Let me summarize. So the DNS mask running inside UniFi Gateway can handle the reverse DNS automatically by generating the pointer record, the PTR record, to support reverse DNS name resolution. However, because it's relying on correct host name and due to different reasons, your devices may not have correct host name in DNS mask. In those cases, if you want rDNS to work, you have different ways, either by correcting the host name or by generating the local DNS record. It doesn't matter whether it's UniFi switch or it's your regular computer client. As you saw in the video, Ubiquiti doesn't provide the consistent UI for UniFi devices and for regular clients when it comes to DNS record, but at the end, technically, they are all simple regular DNS record. And one last thing, in the SSH for the UDM Pro, if I go to this folder, run dnsmask.config.d, you can see there are multiple configuration files. Let me show you the dns.config. There are two things I want to show you. First, the host record. Remember, we added 2 DNS records in this video, right? They are both here, Debian 3 and the switch 1. And there are pre-existing default records. That's where the DNS record ends up with. The second thing is here, the bogus private. So this setting is very important. If you don't have this setting, the DNS mask will forward your reverse name resolution, the rDNS query, to internet if it doesn't know how to resolve it. This video is for rDNS for LAN. Whatever you query, you want it to stay within your LAN. You don't want the internet world know what you are querying for your LAN. That means even if you query something wrong, even if DNS mask cannot find answer, DNS mask shouldn't forward your query, your rDNS query, to internet if it's for LAN. That's what this setting about. Due to the interest of time, I won't show you the video which I already did, which is I removed this setting, I restart DNS mask, and then I try to do rDNS using some random fake IP address. Then you know what? On the one part, I can capture the rDNS query, which was sent from my DNS mask, from my UDM Pro to internet. That's scary, right? You don't want that happen. So fortunately, this setting is default. So don't touch it. Okay, this is the end. Thanks for watching.